Let's solve another medium level problem from LeetCode. It's a copy list with random pointer. So let's understand this problem and then we'll solve this with two different strategy. So in this problem, this is the linked list. And if you see here, there are nodes and this node has next pointer. And also there is a random pointer. So we know here this node next points to this points to this. So next points to the next node, and random points to some random node. So if you see here, this random points to null, and in this case, if you see this random pointer points to 7. So we need to write a code to duplicate this. So if you see, that's the duplicate. We need to make duplicate node for all these things, and then we need to have same connection, like next points to the next, random points to exactly same value with a new node. So that's the problem. And how will you solve the easy one here? There is a one strategy. The strategy one is we'll use additional space. So we'll create a map, and in a map, this node, the existing node, that will be key. And like this is the example 1, 2. Instead of 713, I've just given an example here. 1, 2. There are two nodes here. And in this case, when I create a map, in a map, the key will be the node having value 1. And its value will be another new node. And that has also value 1. And the 2 create another node. And this is the key. And the value will be another new node that has the value 2. So we'll create the map there. And once we have the map, then next, what we do, based on this key, we'll get the value, this one. And we want to connect to the next. I want to connect this new node to this node. And we know this node is, this node, this node is the value of the key 2. And 1 points to this 2. So in this case, we'll get this value 2, and whatever the value gets, this one next points to this. And in the same way, we can do the random for the random pointers. So this is the easy one. Uh, let's write a program and understand like what's happening there, and then we'll see the strategy too. So I'll go and create a map, and this is the map of node, start node, and the key and the value will be also a start node. So I create the map, and then I will run a loop, and I start from here and go to the next until it encounters null. So I'll say, okay, so we'll start with head. So let me create one pointer current, and I store the value of head, and for current not equal to nil. So it iterate current not equal to nil. So first we get this value. So for this, I will store this in a map. So in a map, I'll say this is the key. So the current, whatever the current node, that is the key. And the value will be, for this key, the value will be new node. So I'll create the new node here. Node, and that's the val, next and random. So I'll say the val, and the val equal to current dot val. So from the current, I will get this val and created another node. So I created another node in this way. So for each node, I will put this as a key, and I will also put the corresponding value. So I'll create the new node and put the corresponding value. So in this way, we have all the new nodes created. So we have to move this pointer current equal to current dot next. And so once this node is processed, then current dot next is this, and I put this value to current. So that means current points to here, and then again I'll create another key for this node, and the value will be again new node. So in this way, we'll successfully created a map for this. Okay, so now next thing is assign next and random pointer. So let me copy paste this. Again, I will start from the head. I'll put the head to the current. So current will start from here and current not equal to now. And current next, this is good. And here we need to add the logic. So first of all, uh, we know for this 7 there is a corresponding node also. So we want to get this node, and in this next I want to put something. So first let's get this node. So from map, if I say current, so for this current 7, I'll get the corresponding next node. So like the new node I will get, because that is the value, right? Key and the value pair. So this I store as a key, and the value is this. So if I say the m current, then I will get the value. So this value. So for this next dot next, in this next, I want to put this value, right? Because I want to connect this node to this node, because this is currently new linked list where we have not connected the node, but now I want to connect. So if I say m current next, so m current this, and next we got this, and for this next I want to put this. So this one again I know this is for this value. I want to know the this key, and this key is for this current node to next. So m, and if I say current dot next, if I say current dot next, then this is a current, and next is this one. So this is the key, and corresponding value will be again 13, this one. So that's I connected here. So in this way we connect it to the next, and in the same way we can do for the random. So just copy and paste, and we can do random here, and that's good, and it should work. And at the end we want to return so current, we want to return current. So if I put this current key in a map, then it will return this first node value, right? So this is not the, I mean, this is just a head, so I can just say head. So from the map I can just say head, this head. So if I say the head, it will return this head, new head, and this already connected. So that's all. Accepted, submit. That's nice. So this is very good solution, but the only thing is we are using one additional space for the map, and so that's the strategy one. Let's see strategy two also. So let me comment this code first. Okay, and now we'll go for strategy two. So in a strategy two, here strategy no additional memory, so we're not going to use the map here, but in this strategy we need to have at least 3 paths here. So in these 3 paths, first I do create a copy of each node and link them together. So what I do for this example one, if I have 1 and 2, these two nodes, then what I'm going to do, first I will create a new node, and this node points to this one. So currently you see, currently one points to two, but we change the route. What I do, I say one to point to one, and this one to two, and this two points to this two, and then this two points now. So I'll change the route. So currently, I change the direction. So now currently, if you see one points to two, so I change this. Instead of one pointing to two, or maybe let me put three here also, and three also. Now one point to two, 2.3. Now in a step one, what I do, I change the direction. Now I say one points to new node, and the new node's next is this. And again, for this two points to new node two, and the two points to three, and three points to new node again three. So I'll make this kind of direction. Okay, so first step I will do this, and in second step I will assign random pointers for the copied nodes. So for the copied nodes, I'll just assign all the random pointers. One points to some random. So that's, so when I say the one and the random, then how I do one random, then for this one I will take, I'll say the one and the random. So whatever is a one has the random, there will be, it points to somewhere, maybe three. And then if I say three next, then we know three next is three, right? That's why I made that arrangement, like one points to one and this one points to two. So when I say the three next, then actually you get the new copy here. So in that way, I will assign random there. And then once I have the random assignments, then third is separate the original and copied nodes. So I'll separate this 1 to 3 and this 1 to 3, and then I can return that. Yeah, you can also, you can also dry run this thing, and you'll get the better idea. So let me write the code for this. So first pass is create a copy of each node and link them together. Okay, so first of all, current, that is head, and the for current not equal to nil. Okay, so this time I will create a new node. I can just say that's a copy, and node, and the val is current dot val, and next is, so this time, for the copy, when I create the copy, so for this one, I want to point this one to this two here, right? This one. So I created this new node, but I want to point this to two, because the connection is like when I create this, one points to one, and one, again this new node points to the next one, this current next, right? So for this, as soon as I create the new node, I say that, okay, point to these two, because eventually from this route it has to point to this. So that's why I say here next is current dot next. So new node copy is done. Okay, so first, and the next step is this one, current node point to copy, right? This is our copy, so this points to this copy. So then I'll say current dot next go to copy. Okay, and that's all here. So that's the whole connection we got here. So what's else here in this? Okay, so current next equal to copy, so that's good. Now we want to move to the next node. So the next node is the next node, like I want to move to like one we connected, we have now connection with 1 to 1 and 1 to 2. Now I want to move here, and this is nothing but whatever the copy we have created. Copy dot next is this, so my current will be copy dot next. Okay, so let me put that. So current go to copy dot next. So we created this node. Now I want to see whatever I have done. So if I debug, it's a for the linked list, it's a lot of value we just see in a debug. So just I'm just going to create one function and later I'll delete just for debugging purpose. I will just I'll return some random value. It's no, I know this is a wrong, but let's create a function print, and I can just say head, and this is node for current head, and I can just say for current not equal to nil, empty printf percentage d and current dot val empty println. Okay, so I'm just going to print whatever I have done here so that it makes sense, and I'll just pass head now. Yeah, before this I'll print head here, and we'll see. Okay, I'm expecting result is wrong now. That's okay, but for head, okay, oh, this is print p uppercase. Okay, there is something wrong here. So in a print head, current, oh, so yeah, this one, current dot next. Let's run now. Okay, so before this logic, before creating the new node, this is our structure 713, and after creating the new node, 7 points to the new node, and the new node points to again this 13, and this points to this 13, this 13, and this 13 points to new node 11, and then new node 11 points to old 11. So exactly same structure I mentioned a few minutes back. So we created successfully this thing. Now next stage is we'll just keep it for now, and once we have the correct solution, we'll just delete this print head. So next statement is, or next lines is adding the random pointer. So again, I'll say the current head, current not equal to nil. Okay, so this time for the new node I want. So the new node is current dot next is, if I say in this case current dot next, so this is the new node. New node dot random. So this random is current next. So current next is this, and for this this, okay, current next is the new node, and a new node next is this one. So for the old one, and for the old one next, if I say that is, or old one random I say, then that's a new random. So I can just put current dot next dot, no, current dot random dot next. So if I put this, then random will be assigned. Right. So here you need some thinking here. If I say the current next random, so this is after my logic, and then if I say the current next, this is a new node. For the new node, I want to assign random. So random, and what is a random? So random is so current node. So this is a current node random, whatever is the random. And if I say the next of that, so that next of that is the new node. So that's why I put. But before that, I need to check this random is not nil. So if current dot random not nil, then I can this. Okay, if any error, we'll come back and we'll see that, and then we'll move the current pointer. So current dot next. So that's a random, and uh, current dot. So next thing I want to move is current dot next. So if I say the current dot next, then only I'll be able to go to the second node, like original second node. So dot next. Okay, so that's done. And our the final step is we need to uh, remove that connections. So we separate that old linked list and the new linked list, and then we can return the new linked list. So for that, I can say current equal to head, and I can also say copy current equal to head dot next. So if I say the head dot next, then this is the copy current, right? So I'll put it that here, and also this is, I can just say the new head is equal to head next. And yeah, both things, because the copy current will keep moving, and new head will be still there. So new head will be this one, and later we can return new head at the end. So that's why I just maintain this copy new head here. Now we have logic for current not equal to nil. Okay, that's good. And we want to separate that. Then what I do, from current dot, if I say the current dot next, so now this is one big nodes with the new and old mixed. Now I want to separate. So this 7 points to this 13. So when I say current dot next, so in this time I want to say current dot next current dot next. So if I say 30, then pointing to the old. So the first of all, this I want to maintain. So at least we got old link as it is. Okay, so next step is for the copy. This is the copy current. So for this copy current dot next equal to this copy current next, this one for this 7 points to this 30, like new node. So in this case I can say copy current next. Okay, that's the main logic we handle, and now we just move the pointer. So before that we need to check copy current next not equal to nil. So let me add this condition, not equal to nil. Then come here. Okay, this done. Now we need to move the current pointer. We need to maintain the current pointer. So current, so which should be current? So current should be this, because we already deal with this. So now this should be the current. So the current should be 13 and 13 is copy next. So, or I can just say current next, because that's already make that connection current next here. And current next is current next we maintain here. So that means this 13. And in this way, again, we have to maintain copy current. So copy current is copy current next. So that's the logic. Let's run it. An error come back. New head. So that's a new variable. So we need to put that. Copy current is also new variable. Accepted. Head next. Okay. So we need to handle one more condition in this place. And that here if head equal to nil, then return head. Run it again. Before submit, we are printing this. We'll remove the print, but after uh, disconnecting or separating the old nodes and new nodes, how it looks, let's print this. So print head, and also print, this is uppercase, and print new head. Let's run this. Okay, so this is the head original, we separated that, and this is the new head, and that's also separated, and we got the copy. Okay, so we do not need this print. Delete this. We do not need this print here. And this is the whole code. And remove this function also. This is just for the testing I added. Okay, submit now. It's good. So we can see whole code. Okay, so that's all. Let's see the Java solution also. This is the Java solution. This is using the map, and I have logic is exactly same, but I have added few extra lines. But anyway, this is the same logic what I explained earlier. And approach 2, this is approach 2. Okay, so that's all for now. Thank you.